Vishwanath not came.
Getting goods.
Venkatesh?
Both.
Both. Okay. Very good evening, everyone. Very good evening, Kamlesh, Aditya, Kirutika, Kalpana. Very good evening. Am I audible? Sir, very good afternoon. Okay. Okay, students. So yesterday, we have seen only linear motion of the mirror and object. No? Today, rotatory motion. Today, let us see rotatory motion. See, I will take one plane mirror. What is this? Plane mirror. Here somewhere object O is there, point object. What is the name of this ray? Respond. Very good. Incident ray. What is the name of this point? Point of incidence. How x-axis is important in maths? Like that, normal line also that much important. In fact, normal line also a vector quantity which is away from the surface. And one more advantage, to measure the angle, that normal line is acting like a reference axis. So what is the angle between them? Is called angle of incidence. According to laws of reflection, angle of incidence equal to how much? Angle of reflection, that is how much? Small I. Both are same only, no? Angle of incidence equal to angle of reflection. So this is called reflected ray. Now, what I will do, I will rotate the mirror. I will keep object rest. What I will do, I will keep object at rest, first case, and rotating mirror. Rotating mirror. So tell me what will happen. I rotated the mirror like this. This is the new position of the mirror. M1 is the initial position of the mirror. M2 is what here? New position of the mirror. So M1 is the initial position of the mirror. And what about M2? Final position of the mirror. What is the rotation of this mirror? Kindly respond. Angle theta is the rotation. This is also how much? Theta. What is the new normal line? Normal line also, N1 is the initial normal line. N2 is what here? Final normal line. So normal line also rotated by how much angle? Angle theta. Then what is the new angle of incidence? Kindly tell me what is the new angle of incidence? Angle between normal line and incident ray. I plus theta, na? A plane mirror. Okay. Please be patient for beginning onwards. I will explain. Okay. Okay. So this is the initial position of the plane mirror, right? This is one incident ray. Which ray? Incident ray. Normal line is compulsory, na? Yes or no? This is which line? Normal line N1. What is this angle? I. According to second law of reflection, how much? Angle of incidence equal to how much? Angle of reflection, both are same. Now what I am doing? Mirror I rotated. Yesterday, mirror is moving in a linear motion. Object is in linear motion. But hereafter, rotatory motion. Are you understanding? Mirror I am rotating. Object also I am rotating. But in this case, object I am keeping rest. Means incident ray I am keeping rest. Means incident ray keeping rest. Incident ray keeping in the state of rest. What I have done? Come on, respond. What I have done? Mirror alone I rotated clockwise. What is this? Tell me. New position of the mirror. It is rotated in which direction? Clockwise angle theta. Clockwise angle how much? Theta. Yes or no? What is the new new normal line? Normal line, new normal line also. If mirror is rotated angle theta means normal line also rotated how much? How much angle? Theta. Understood? Now tell me what is the new angle of incidence? You have to guide me. What is the new angle of incidence I am asking? I plus theta only, na? Yes or no? Angle between this incident ray and new normal line. How much? I plus theta. Understood or not understood? So new angle of incidence is I plus theta. Where is the new reflected ray? This is the reflected ray number 1. What is the new reflected ray? It will be like this somewhere, no? Kindly say yes or no. RR2 means what? Second position of the reflected ray. I want to find what is the angular displacement of this one. I will assume unknown value x, na? What is the x value? Tell me, guide me. What is the x? No. Think and tell. This is I means this angle how much? I minus theta only, na? From this I have to subtract theta only, na? This angle I am telling. Understood or not understood? This angle, this angle equal to how much? This angle minus this angle. Is my point very clear, na?
Yes, sir.
Now I want this angle x. How much? Tell me one plan how.
I minus theta plus 6. The 2
Hmm? Can you say what is this angle?
theta. The 2 theta.
How?
Sir, angle of incidence is equal to angle of reflection. So then I plus theta is equal to I minus theta plus 6.
Yes.
IA gets cancelled. It's equal to
Okay, I forgot. Angle between new normal line, this angle between new normal line and new reflected ray also, how much, tell me? Very good, I plus theta. I mean, from I plus theta, I have to subtract this only, na? Understood the logic? Huh? So I can write that point. X is equal to how much?
I plus theta.
Very good, I plus theta. From I plus theta, I have to subtract what here? This angle I have to subtract, na, means I minus theta. So x equal to how much? I plus theta minus I plus theta. Minus I plus I cancels. So x equal to how much? 2 into theta. Understood? This is nothing but angular displacement of the reflected ray only, na? I mean 2 into theta. I will assume this is equation number 1. What is the angular displacement of the mirror? Plus theta, na? Here mirror you rotated clockwise. Reflected ray also rotated clockwise. If you divide them, what will happen? Theta, theta cancels out. So, what is the angular displacement of the reflected ray? Tell me. 2 into angular displacement of the mirror. Okay. If angular displacement of the incident ray, how much? 0. Is a very, very powerful point. Everyone should remember at your fingertips. It's similar to displacement of the mirror equal to displacement of the image, reflected ray representing image only, na? Yesterday we discussed displacement of image equal to how many times? 2 times of displacement of the mirror, na? Correct or not? Analogous concept. Yesterday mirror rotated x meter means image will displace 2x meter. Here also same, na? Mirror rotated theta, image rotated 2 theta. Reflected ray, where it is pointing, that is image only, na? Correct or not? So both are analogous concept and easy to remember also. Okay, understood? Now let us see one more case, reverse case. What I will do, now mirror is rest. Now mirror is rest. Now mirror is rest. Which is rotating? Object is rotating. Shall I call object as incident ray with your permission? Say yes or no? If you rotate here, somewhere object is there. If you rotate the object, automatically incident ray also rotates, na? So mirror is rest, object or incident ray rotates. Okay. One simple example I will explain. This is a plane mirror. Which mirror? This is a plane mirror. Let's say this is one. What is the name of this ray? Incident ray. What is the name of this line? Normal line N1. What is the angle of incidence? Tell me. I. What is the angle of reflection also? I. Now I rotated left side. What I have done? I rotated the object anti-clockwise. Say yes or no? I rotated the incident ray. This incident ray in which direction? Anti-clockwise angle theta. What is the new reflected ray? It will be like this only, na? According to symmetricity, What is the angular displacement of this reflected ray number 1? Also theta, no? Incident ray rotated anti-clockwise theta means reflected ray rotated clockwise angle theta. Yesterday I explained, na? If object is coming 2 meter per second means image will go minus 2 meter per second. Same concept. Are you understanding? So shall I write one max statement? Angular displacement of reflected ray is equal and opposite to angular displacement of the incident ray only, no? Why opposite direction? Negative sign I kept. Incident ray rotating anti-clockwise, but reflected ray rotating clockwise. When respond? When angular displacement of mirror equal to 0. It is also powerful point. Kindly remember at your fingertips. So these two simple cases, now I will fully combine, fully mix up. Both motions are there now. Which motions? Two motions will exist. What is the now complex case? Both incident ray and mirror in rotatory motion. Okay, before that, one small modification. What is the angular displacement of reflected ray? 2 into angular displacement of mirror, na? If you divide with time on either sides, what will happen? Angular displacement by time. Angular velocity of the reflected ray equal to how many times? 2 times of angular velocity of the mirror. This is another modified format. If you again differentiate with time, you will get angular acceleration also. Angular acceleration of the reflected ray equal to how many times? 2 times of angular acceleration of mirror. This case I will take. What angular displacement of reflected ray equal to? Angular minus of angular displacement of image. If you divide with time, what will happen? On either side, if you divide with time, what will happen? Angular velocity of the reflected ray equal and opposite to angular velocity of image. Okay. Now mixed case. Mixed case in the sense both mirror is rotating, incident ray also rotating. Understood or not? So if you take any plane mirror, this is which ray? Respond? Incident ray. This is which ray? Which ray? Reflected ray. Now angular velocity of the mirror is 2 radians per second clockwise, and angular velocity of the incident ray 1 radians per second. Everyone find angular speed of reflected ray quickly, and direction also. Clockwise, huh? Shura, Pakkava. Okay, now I will do this. Because of mirror motion, because of only mirror rotatory motion, what is the angular speed of this reflected ray? 4 and clockwise, no? Correct or not? Understood? 2 times, no? And because of this incident ray rotatory motion, opposite direction and 1. So 4 plus 1, 4 is clockwise, 1 also clockwise. But resultant velocity? 5. So what is our answer? Angular speed? 5 radians per second. And what about direction? Clockwise. Understood or not understood? Clear? One small practice problem I will give. Everyone have to answer correctly. No excuse. Okay, because concept I explained nicely, one practice problem I solved nicely. I will not accept if you tell incorrect thing. Listen question carefully. Ready? Huh? Ready? Huh? Incident ray rotating with 10 radians per second clockwise. Huh? Understood? Huh? Reflected ray rotating with 1 radian per second anti-clockwise. Find angular speed of mirror. What's our you did all easy problems. Huh? Find angular speed of mirror and direction. 2 minutes time.
uh, 4.5 radian per second.
4 point
5 radian per second.
clockwise and anti-clockwise. Karate practice, no? Vishwanath is this treatment is there, no? You know this treatment. If you have any disease, no, what's the name of one therapy is there? I don't know that. If you have headache, no, he'll take one pen and he'll point your head and he will oscillate like this. Okay. Come on, give your answers. Are you supporting a Kamlesh? Never, 1 point? 5.5 clockwise, Venkatesh. No. Right.
Displacement
Aditya, you 5.5 clockwise, huh? Okay. Okay, it is my turn. I will assume any wrong direction or correct direction. I will assume angular speed of the mirror is some x and going clockwise. If I am wrong means I will get my answer negative sign. Are understanding? Now tell me, because of x, because of the rotational motion of the mirror, what is the angular speed of this reflected ray? Tell me. Clockwise and 2x, na? Because of only incident ray, what is the angular speed of the reflected ray? Very good. Minus 10. So 2x minus 10 should be equal to how much? Sir, 10 minus 2x equal to 1, no? This is the resultant velocity. Means, I will write down here. Resultant velocity how much? Clockwise. Correct? 10 must be, sorry, resultant velocity anti-clockwise. So 10 is bigger only, na? And 2x is little. Net velocity, which direction is there? Big velocity also that direction, na? So I can write net angular velocity how much? 10 minus 2x I can write. But net angular velocity 1 is equal to how much? 10 minus 2x. 2x equal to how much? 10 minus 1. So 2x equal to how much? 9. So x equal to how much? 4.5. Yes or no? That is our answer. Clear or not? Means I got positive answer means definitely my assumption is correct only. Clear? If the mirror rotates clockwise with 4.5, definitely reflected ray also 1 radian per second it will go. If it is anti-clockwise means try. 2 probable answers you will get, no? If a mirror I assume rotating anti-clockwise now, you will get different answer. 5.5 you will get. Correct or not? Both are correct answers only. What is the net angular velocity? Tell me. 1, na? Now this time what I did, I will assume mirror rotated anti-clockwise. Mirror rotated anti-clockwise means how much? Because of mirror rotation, 2x will come. Reflected ray angular speed. This step understood, huh? And because of incident ray rotation, clockwise will come and 10 will come. But here, which is very big? 2x. So 1 I can write 2x minus 10. So 2x equal to how much? 11. X equal to how much? 5.5. Both are correct answer. Understood. Here many students, this is a slipping zone, mind bending framing of option. First option, if one student got 4.5 clockwise is there. Second one 5.5 anti-clockwise is there. Third one 4.5 anti-clockwise is there. Fourth one 1 and 2 are correct. With your excitement, what will you take? Either 1 or 2 only will take, na? But actually, which is right answer? Fourth one is correct answer. Both probabilities are there. Understanding or not understanding? Both are correct answers. So here both are right answers. But 5.5 means anti-clockwise. This is wrong. This is correct only. Kamlesh is correct. Partially correct. Understood? Huh? Copy everything. I need full board.
Sir, in the second case, due to incident ray, that must be in anti-clockwise movement, sir. 10 radians per second. We took in clockwise.
Okay, okay, wait a second. He was correct. Correct. Very good. Some small corrections to this. Correct only. If the incident ray going clockwise means because of incident ray rotation, reflected ray should be anti-clockwise and 10, no? Then 2x plus 10 equal to 1. 2x plus 10 equal to how much? 1. 2x equal to how much then? 9. Sorry, minus 9. X equal to how much? Minus 4.5. Then same answer. Only. Correct only. Then 4.5. Our assumption is wrong, na? We got negative answer meaning? Yes. So 4.5 clockwise. You also got a Vishwanath? Okay, Kamlesh is the right answer. Very good. If I rotate the mirror like this, is there any change in the experiment? Mirror is there. As of now, you are rotating like this, na? Change is there. If you rotate the mirror like this, no change. Reflected ray speed will not change, no? Are you understanding? Write down that point also. If you lift like this, definitely like this also change will be there. I'm telling if you rotate like this, no change in reflected ray motion. It's a reflect mirror, huh?
Flip it is asking it will reflect. Same.
Hey, how it will reflect? Right? That is a back side will come, no? Okay, so that is a reflection on the smooth surface. I mean plane mirror. Now reverse case. Over copy speed. Finished, huh? Okay. So let me introduce the next concept is reflection on plane surface is over, no? Now reflection on curved surface. Curved surface. So I will take one sphere. What I will do? I will take one sphere like this, hollow sphere. Okay. This portion I will intersect. Be careful, it is not a circle. It is a perfect hollow sphere. I removed this portion. So what you will get? You will get one spherical mirror. If outer surface is painted or silvered with a ferric oxide, so this inner surface is acting like a smooth surface or polished surface. It is acting like a mirror. Correct or not? If you extend this edges, again you will get the perfect sphere. The center of the sphere is called what here? What are you eating? What is that? Minta. Very good, very good. Correct one. What is the center of the sphere is called? Center of curvature. Every distance you have to measure from one particular point is called what here? Pole. That is also called origin. The imaginary line which is passing through this center of curvature and pole is called very good principal axis or x-axis or anything. Understood? This is a which axis? Y-axis. Is without x-axis and without y-axis, we cannot do anything. Every distance is measured from the pole only. For example, if parallel light rays are coming, one parallel incident ray fallen. What the name of this point? Tell me. Point of incidence. At this point, what a normal line? On normal line on any sphere, must and should passes through the center. So this is a normal line. What is the angle between incident ray and normal line? Tell me. Angle of incidence I. According to laws of reflection, angle of incidence must and should be equal to what here? Angle of reflection. So this is also how much? I. Understood? And if you see this point where the very good point of focus or focal point, the distance between the center of curvature and pole is called what here? Radius of curvature, capital R, and the distance between the focal point and pole is called focal length. In fact, this is also small f. So I can write R is equal to how much? F plus F 2F. Very good. So I can write focal length equal to how much? R divided by 2. So the one important note for concave mirror, which side focal point is there? That is the real focus only, na? Real focus means all the real focus means all the reflected light rays must and should passes through this point of focus truly. Really they are penetrating through the point of focus, na? That's what it is called real focus. That is a very, very important note. Very, very important note. Concave mirror is having real focus, not a non-real focus. Two kinds of focus are the real focus and virtual focus or non-real focus. Both are same. Understood? This focal point is on the negative x side, no? So another important note, focal length is always negative. Always negative. In any numerical operations, focal length is 5 centimeter means what you need to substitute? Compulsory -5 you need to substitute. If you do not substitute, biscuit will happen. So be careful. Okay? Clear or not? Answer will be there. What you obtain answer, but that is incorrect. Understood? Now let me introduce some ray diagrams, some rules to draw ray diagrams. Rules to draw ray diagrams. This is any concave mirror. How many points, major points? Kindly respond. Pole, focal point, or sometimes real focus also they will call. And this is center of curvature. What is the imaginary line joining principal axis? For example, no. If any ray of light falling and passing through point of focus, how it will bounce back? Shabash, parallel to principal axis. Why? Here, if you do little analysis, you should draw a normal line first, na? What the name of this line? Normal line. Any normal line at point of incidence must and should passes through the center of curvature. This is the angle of incidence I means. So the reflected ray must and should go parallel to the principal axis. So that is also how much? I. That is rule number 1. Rule number 2 means reverse case. Reverse case means parallel means passes through the point of focus. That is principle is called principle of reversibility. What the name of that principle of reversibility? I mean, incident ray, reflected ray can be swapped. If incident ray become reflected ray, then reflected ray also become incident ray. So principle of reversibility. Principle of reversibility. If you take any concave mirror, usually pole, point of focus, and center of curvature. If any ray of light is falling parallel to the principal axis, how it should go? Passes reflected through the point of focus. Rule number 3. This is a concave mirror. What is that point? How many major points? Pole, focal point, center of curvature, real focus also you can call. Any ray of light incidenting through center of curvature. Where is the normal line? Kindly tell me. At this point of incidence, what a normal line? Normal line also must and should pass through the center of curvature. Say yes or no. What is the loss of reflection? Angle of incidence here 0, no? Means the angle of reflection also must and should be 0. Mean how it will go? In which path it will travel? In the same path it will bounce back. Correct or not? That is another rule. And one more point. This is any concave mirror. As usually, how many points are there? 3 major points. Pole, focus, real focus. Be careful. See. And if any ray of light is falling on the pole, what is the normal line? Kindly address me. This is only normal line, na? Say yes or no. Any normal line must and should passes through the center of curvature. So angle of incidence how much? I degree. So automatically how it will go? Same with the same angle of reflection also, na? That is the all rules. Similarly, if you see convex mirror, which mirror? If you look into the convex mirror, what the convex mirror tell me? Yes. You take any segment of the sphere. Now this side inner surface is painted with ferric oxide. So outer surface is acting like a mirror. If you extend the edges, what do you get? Tell me. Kindly respond. You will get one sphere at point P. Sorry. Center of curvature what? C. So center of curvature right side. Where is pole? Kindly respond here only, na? In between them, focus. Be careful. Virtual focus F prime. F prime is be careful strand. You should not call focal point. Real focal point, virtual focal point. Why I am calling virtual focal point? Tell me. Not real. It's called virtual focus. I will tell you the reasoning. I will tell you the reasoning why. If parallel light rays are falling, what is the normal line? Tell me. Normal line must and should go through the center of curvature like this only, na? This is what angle of incidence? I. How it will bounce back? Tell me. With the same angle, na? Say yes or no? Have you noted? This ray must and should pass through this point of focus, apparently. Truly not going. Correct or not? Really not going. So that's what this point is called what here? Virtual focus. So convex mirror is having only virtual focus. There is no real focus for convex mirror. Are you getting my point? Understood? So focal point is right side, na? So for convex mirror, focal length is plus or minus? Plus you should take. That is a very, very important note. The small things only you should know. Focal length for convex lens is always what? Positive. Is positive and virtual. Say yes or no? Okay. Copy quickly.
Yes, I is equal to 0, R is equal to 0.
Hmm.
There are no angle.
No angle. Angle between incident ray and normal line is zero only, na? So angle of reflection also should be zero. Over. Okay, students. So some images we'll see. For example, if image is at infinity, see this is any concave mirror. How many points are there as usually? Pole, real focus. Please be pronounced properly. What is this focus?
Real focus, center.
Real focus. Kindly remember, if the object is at very infinity distance, I mean very far. Infinity means what?
Above 7 meters.
Above?
7 meters.
Shabash. Any object to you more than 7 meter means what? Like any far tree, far building, everything, flying bird more than 7 meter means that is a far object. Every far object will produce what kind of light? Only parallel beam of light will produce. Kindly remember that point and add a note also. So from the object, farer light will come. According to rules, this reflector ray must and should pass through the point of focus. So here real image will form. Why real image is forming? Reflected light rays are truly meeting, no? So what is the nature of the image? That is real, and all real images are which images? Inverted images. Are understanding or not understanding? Inverted. Remember this point also. And what is the size of this image? Here the object is very much bigger, but the image is highly diminished or point size. Image is point size, where it is formed at point of focus. Okay, that is the first case if object is what? At infinity. Now the second case, if object is just beyond center of curvature. If object is what? Just beyond the center of curvature. This is one concave mirror. What is the name of this axis? Principal axis. This is one pole and point of focus. What is this? Center of curvature. Where is the object here right now? Just beyond C. Usually in our laboratory, we will use one iron nail as an object. That too, this head of the arrow is there, na? That is the tip is our object. Example, one ray of light is coming from the head of the arrow. One is parallel. How it should go? Must and should go reflected through the point of focus. Yes or no? And another one, let's say it's incidenting through the point of focus. How it should go? Parallel to the principal axis, na? Where the reflected light rays are meeting? Between C and F. So that is only real image. So the reflected light rays are real emitting. So it is a real image. All real images are inverted, ulta only. And not same size. Object is very far means image is near means image is diminished. Image is near to the pole, no? So it is diminished. And where it is formed? Between C and F. Now slightly I will bring the object closer. I mean at C. Where I have to bring? Third case. If object is at C. If object is at C. If object is at C, this is one concave mirror. Usually this is the imaginary line. What is the name of the point? Pole, point of focus, and center of curvature. Where the object I have placed? At center of curvature like this. One ray of light falling like this. How it will go? Through the point of focus. Any ray of light passing through the point of focus, how it will go? Parallel to the principal axis. So the where the reflected light rays are meeting, that is your image, no? Kindly say yes or no. So what is the character? Real and very good inverted, same size. Why same size? Object distance, image distance, both are same only, na? So real and inverted, same in size. Same in size and at center of curvature only. This is the center of curvature only, na? Now, if object is placed between, very good, C and F or F and C. Is any concave mirror? This is the principal axis. This is the pole. This is the point of focus. This is the center of curvature. I placed the object here. One incident ray falling like this. How it will go? Passes through the point of focus. And one more ray of light. That is of your choice. At P you can take, at F also you can take. Your choice. Nothing will happen. So according to laws of reflection, it will meet somewhere. That is a, have you seen the size of the image? Real. And all real images are what here? Inverted and highly magnified or magnified. Where it is formed? Very good, beyond C. Now, next one is where the object has been placed, tell me. At point of focus, sorry, real focus. You should mention crystal clearly, students. Sometimes you will mention virtual focus of the concave mirror. So that side. In the question will be mind bending in your exam. You will mention for concave mirror, virtual focus, he will tell. Where is real focus? Left side. Where is virtual focus? Right side. Are you understanding? You should be very, very cautious here. That's what you have to specify when you pronounce only. Are you understanding? If you take convex mirror, where is real focus? Sorry, no real focus. No real focus, only virtual focus. That's all. Clear? Sometimes he will confuse us. So you should not confuse. Next one, where I have to place if object is at which, if object at point of focus. So this is any which mirror? Concave mirror. What is the name of this axis? Principal axis, pole, point of focus and center of curvature. If you place the object at point of focus, one ray of light is parallel. How it should go? Parallel to the principal axis. Have you noticed this two reflected light rays? Both are very far, no? They will meet at infinity. What is the nature of this? Same real. There is one misunderstanding. Parallel beam means many children they will feel they do not meet. It is wrong. They will meet 100%, but very larger distance. Means real image only will form, na? Says or no? So real image only will form. All real images are what here? Inverted and highly magnified, no? Why highly magnified? Image distance is more than object distance. So definitely highly magnified. Where image is formed at infinity. Now next one, if object is in between point of focus and pole. It is a peculiar case in concave mirror. Pole, point of focus, center of curvature. Where I placed? Here somewhere, na? Object. If any ray of light passing parallel, how it should go? Through the point of focus, na? Yes or no? If any ray of light falling at point P, it will go like this, na? So reflector light rays do not meet each other, na? Really? So here no real image will form. Which image will form? Those are meeting apparently. So here this case alone is called shaving mirror case. Shaving mirror case means if you keep your face in between focal length, sorry, in between real focus and pole, you can see your image of your face highly magnified and well defined. Are you understanding? Okay. So what is the character of this image? Virtual.
Yeah.
And all virtual images are erected only, na? Object is above the x-axis. Image also now above the x-axis, not below. So virtual and erected. Magnified or demagnified? Magnified. Location you cannot say, just I will write just behind the mirror. Understood or not understood? Say yes or no? Now convex mirror has only one case. All images are over for concave mirror. Now which mirror? Convex mirror. I will take one concave mirror. It has how many points? Tell me. Pole, sorry, virtual focus and center of curvature. Clear or not? Numerical, sometime you will create real focus also. You will create which focus? Real focus also. Understood? Now listen. If you keep any object like this, an arrow, one ray of light will fall like this. How it will go? Compulsory, apparently reflected through the point of focus only, na? Say yes or no. And if any one more ray of light falling at the pole, how it will go? According to laws of reflection, angle of incidence equal to angle of reflection. Do they meet really? This reflected ray number one, reflected ray number two, they do meet really? No. So only apparently only they will meet. So this is the virtual image. Correct or not? What do you notice? But the character of the convex mirror is always virtual, always erected, and always diminished only, na? There is no chance of always diminished. And where it is formed in between pole and virtual focus. My point clear? I will send the screenshot to you. Later you copy. Clear? Huh? This only, na? Sure? Huh?
Yes, sir.
Ma. Ma. Okay, later in your free time copy. Okay. So now let me introduce one very, very important concept. What that concept is called? Vishwana, buy one sprayer, water sprayer.
What is
Water sprayer, you know. Who are feeling more sleepy, drink more water so that you will be always activate. Understood? Second point, okay, clean your face. Two advantages. Your sleepiness will go and your skin also will be detoxified. Are you understanding? And you will be always active. Give it to him. For you, it is useful now. Huh? Okay, so now let me introduce the next concept, mirror formula. Which formula? Mirror formula. What is the mirror formula? Or else soak the kerchief in water and clean. Why? Because this is nicely you had lunch. Everyone's situation like that only. That is not your mistake or my mistake. Situation mistake. Understood? Okay. So keep it always, wipe it. Okay. Mirror formula. What is the, for example, this any roughly I will take a concave mirror. Somewhere I will take the object O. What is object distance? U. Negative or positive?
negative?
Compulsory should take negative value only in the numerical. Somewhere focal length is there. Focal length is how much? Negative or positive?
Negative.
Compulsory negative. The distance between the pole and focal point is called
Focal.
focal length. Somewhere image is formed here. What is the distance between image and point P?
V.
Image distance. So V is called what here? Image distance. U is called what here? Object distance. F is what here? Focal length. So by relating this, one relation is there. 1 by F equal to how much? 1 by U plus 1 by V. This is called what here? Mirror formula. Very, very powerful formula. You should compulsory remember at your fingertips. And the next term is linear magnification. How will you place the object along y-axis only, na? This is y-axis. This is which axis? X-axis. Where is z-axis is? Coming out of the paper. Understanding or not understanding? Okay, so you can call this is linear magnification. Many names are there. Or vertical magnification. Or magnification along y-axis. What is the magnification along y-axis? Height of the image by height of the object equal to minus image distance by object distance. This also remember. Magnification means how many times image height or image size has been increasing. Yes or no? Now, one problem I will give, JE problem. Okay, so kindly answer. This is which mirror? Tell me, this is which mirror? Convex mirror. Its focal length, let's say 10 centimeter. Some incident rays are falling like this. What the name of this rays? Respond. Incident rays. Incident rays. They are about to meet one particular point. Where the incident rays are meeting, that is a object only, a virtual object only. No? What is the definition of object? Where the point where incident rays are meeting is called object. But here they do not meet really. No? So it is what a type of this object? Very good, virtual object. Virtual object. So what is that virtual object distance is? Some 10 centimeter. Find image distance. Come on, quick. Find image distance. Okay, I will only do time over. What object distance u is equal to? I should take plus 10 minus 10 plus 10. Why? Object is positive x-axis, plus 10 you should take. What about the focal length of the convex mirror? Compulsory right side only, na? So that is also plus 10. Image distance I asked you. What a formula? 1 by f equal to 1 by u plus 1 by v. 1 by 10 equal to 1 by 10 plus 1 by v. So 1 by 10 cancels out. 1 by v equal to how much? 0. So v is equal to 1 by 0 infinity. Understood? Means the reflected light rays are about to meet infinity. Understood? Yes or no? What the height of the image? Height of the object into minus v by u, no? V value if you put height of the image also very big. Infinity means what I told you. Very, very big. Okay, so have a break. This thing also I will share. Eaten your time. Thank you, students. You can leave. What, Aditya? You say something? Time over. Have your break. Roam here and there. Especially Vishwanath, go.